Okay, let's now look at the last question of the quiz, which is question 7. Okay, the keyword in this question is a system in a state of equilibrium. So how do we interpret if it's in a state of equilibrium? It means that this whole beam has to be balanced, or it has to be seen as totally horizontal. Okay, it cannot be slanting one side, which is the keyword equilibrium. So once you know that it's equilibrium, there's a principle that we need to apply to solve the question later on. Okay, let us move on to part A. Calculate the anti-clockwise moment. So which side gives you anti-clockwise moment? There are two forces here, 4 Newton and 8 Newton on the right. And the keyword here is anti-clockwise. In order to create an anti-clockwise moment, it has to turn on this direction. So this direction is anti-clockwise. So you look carefully, if this is my pivot, which is a fixed turning point, only 8 Newton is able to provide for me a anti-clockwise moment. So it's turning about, the force is acting outwards and it's turning in a anti-clockwise direction. So in this case, I write down my moment is equal to my, in this case my formula is force times perpendicular distance about the pivot. So I take force, which is 8 Newton, times my perpendicular distance to the pivot, which is 0.3 meters. So my final answer is 2.4, because this is in Newton and this is in meters. So my final answer is 2.4 Newton, capital N, and meters. So this is how I solve for part A, which is just finding a moment, which is force times perpendicular distance. Okay, let's now move on to part B. Write down an expression for the clockwise moment in terms of y. You look carefully, if 8 newtons give you the anti-clockwise moment, so in this case 4 newton has to give you the corresponding balancing clockwise moment. So this one will give you your clockwise moment. So clockwise moment will be equal to, so it's equal to same, the force times perpendicular distance in this case is 4 times y. So the answer is 4y Newton meter. Okay, so this is the answer for part B. So let's now move on to part C. Write down an equation. Equation needs to have an equal sign. How do you know that it's equal? Because of the keyword equilibrium. Equilibrium, there's a principle called principle of moments. What does principle of moments say? It says that the anti-clockwise moments must be equal to your clockwise moment. So in this case, I can equate what I have gotten in part A and part B together. So in this case, anti-clockwise moment is 2.4. And my clockwise moment that I calculated in part B is 4y. So this is my answer for part C, which is 2.4 equal to 4y. Okay, let's now move on to part D. Hence, solve for y. So if I have an equation here, how do I solve for y? So I put 4y, the subject, equal to 2.4. So y is equal to 2.4. This is multiply. So if multiply and move it to the right, it becomes divide. So it becomes 2.4 divided by 4, and the answer is 0.6. And notice y is actually a distance. So this unit has to be in meters. So 0.6 meters. So this is the answer for part D.